All right, this is the Honors Purple Chapter 1 review. This one goes out to you, Nick, because you requested it, so here we go. Number 1, what is the value of negative 2 to the 6th power? And then it also says this. We want both of these. These are totally different problems, aren't they? Remember, don't overexert or underexert the power. This power goes to the parenthesis, which means the negative 2 is going to the 6th power. That's a negative times 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 a negative. That's 6 of them. So guess what? It's going to be positive. So you would just do 2 times 2, which is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. And it's positive because we had 6 negatives. Remember, this is different. This 6th power is not hitting that negative. This is 2 to the 6th power, which is 64. That makes it the opposite of it. So this would be negative 64. In other words, be careful how much your power goes to. Number 2, write 50 big number 6 bouquet in scientific notation. Remember, your decimal has to be make it between 1 and 9.9 repeating. Can't be a 2-digit. And so now times 10 to a power. The power up here is not the number of zeros. It's the number of places you move the decimal. So from there, I need to move it 3, 6, 9, 10 places. That'd be 10 to the 10th power. Third one, square root of 9 over 36. Remember, you can do this as the square root of 9 over the square root of 36. The square root of 9 is 3. Square root of 36 is 6. Now, once again, remember there could be a positive or a negative answer to this. They didn't ask for both of them, so we usually assume that that is positive. Of course, 3/6 can be simplified to 1/2 as well. Could be positive or negative 1/2 though. All right, second one, approximate square root of 70. I'm going to go through that process real quickly. Well, 70 is between the perfect squares 64, which is 8, right? And 9, which is 81. So if I do a subtraction problem to figure out how many numbers are between 64 and 81, I get 17. And so when I do, excuse me, when I do how far along that continuum from 64 to 81 I am, 70 minus 64, I'm 8 out of 17 away. That means it's going to be just under a half, because 8/16 would be a half, right? Or 8/17, so it's going to be 8 point close to 8.5, but it's 8, and 8/17 would be a pretty good estimate. All right, next one, square root of negative 25. Can you have a square root of a negative number? No, your answer is no real solution. No real solution. Can you have a cube root of a negative number? And the answer is yes, because a negative times a negative times a negative is still negative. So I want to know what times itself again got me negative 512. Well, you might not know which one that is, so you would work with some of them that maybe you know. 7 to the 3rd power. 7 times 7 is 49, times another 7 is 343. So maybe we try 8. 8 to the 3rd power. Well, 8 to the 3rd power, 8 times 8 is 64. 64 times 8 again. Look what we're going to get. 512. So it is 8, and it's negative 8, because the cube root of a negative number will be negative. Next one, approximate the cube root of 303. Well, I'm probably going to just get to the nearest whole number on this one. I just did 7 cubed over here, and it was 343. So it's going to be between 6 and 7, right? So 7 was 343. 6 cubed, well, 6 times 6 times 6 is 216. Now we just need to figure out, is it closer to 216 or is it closer to 343? Well, it's only 40 away from here, right? It's much further than 40 away from here. So we would say this rounds up to 7. Let's see, what number am I on? Number 4, right? 0.631 repeating. Let me just keep writing it out a little bit. As a fraction, so to review, we set n to be that number. If there are 3 numbers repeating, I'm going to take it times 1,000. That would get me 631.631631 dot dot dot. Now I'm ready to subtract. When I subtract, all of this stuff cancels out. And I'm left with 631 equals 1,000n minus 1n is 999n. And then 631 divided by 999, because of course you divide to get rid of that. Divide and there's your fraction, 631 over 999. The area of a square is 62 units squared, feet squared. To the nearest foot, what is the perimeter? Make sure you answer the question. I don't want just the length of a side, I want the perimeter. So I need to find the square root of 62 to find out what one side is. So 62, let me go ahead and do that. Well, I know it's going to be really close to 8 because 8 is 64, right? 7 would be, 49. So once again, we're 15 between these two, and I am 13/15, right? So it's really close to 8. So 7 and 13/15 would be a pretty good estimate. Now I need to take that times 4, don't I? Because I have 4 of those sides. I'm going to use my distributive property. 7 4s, or 4 7s I guess I should say. It's 28. And then I would have 52 25ths. Right? 52 25ths. 52 15ths I believe they are, sorry. 52 15ths. So when I do that, I'm going to get 3 and 7 15ths, so it's really close to the middle. 28 and 3 is 31, and 7 15ths, so 31 or 32 because it's right there in the middle. We'd actually have to work that out a little bit more precise to get that, whether it actually rounds to 31 or 32. All right. Number 6, how many times larger than 4 million is 8 times 10 to the 9th? Let me write that 4 million in scientific notation. That would be 4 times 10 to the 6th. And I want to know how many times bigger 8 times 10 to the 9th is. That means I need to do a division problem. How many times bigger? Well, 8 divided by 4 is 2. 10 to the 9th divided by 10 to the 6th. Remember, we subtract and you get 10 to the 3rd. So that's how many times bigger it is. 2 times 10 to the 3rd. Of course, you could do that, work that out. 2 times 10 to the 3rd would move the decimal 3 places, about 2,000 times bigger. 3 numbers from each of the list, whole numbers. 0, 1, 2. Integers. Now you could list all those. I'm going to list some other ones like -7, 2, and -3. Rational numbers. Any of these are rational because you can write them as a fraction, but you could write like 2/5 or even 0.67 repeating. Or 5. Some easy ones. Irrational. Irrational would be like pi, never ending, never repeating, or 0.271643, never ending, never repeating. Square roots of things that aren't perfect squares come out like that. Square root of 2 would be another one. Real number, there. All of those are real numbers. And counting natural are this exact same list as whole number except no 0. So like 1, 2, 3, 4, 5, the things you would count with. All right. I need another sheet of paper. I guess I'll use this paper. Okay, so I should have written this to where you can see it. Actually, I'm going to get up and get another piece of paper. All right. I'm going to simplify a couple of these, so bear with me. I should have written them ahead of time. First one is 2mn to the -2nd times 3mn to the -1st, 4m to the 4th, n to the 3rd. So here's what I always say. Draw yourself out a couple fraction bars out to the side, and let's simplify this little by little. I'm going to do the parentheses first. This is a product, or a power of product, because I'm going to have to go all, it's kind of like the distributive property. This would be 3 to the -1st, so I'm going to write it on the bottom as 3 to the 1st. M to the -1st. So once again, I'm going to write it on the bottom. I don't really need the 1. It's an understood first power. N to the -1st, so I'm going to write it on the bottom as a positive power. Now I'm going to start moving other things that have negative powers. This n to the -2nd goes to the bottom as an n to the 2nd. So I've taken care of that. I've taken care of that. I still on the top have a 2 and an m. On the bottom I have a 4 and an m to the 4th and an n to the 3rd as well. So let me combine all of this stuff now. This m will cancel out this m right there. I could simplify this 2 and this 4 because neither one of them have a exponent. So let me just make that into a 1 and a 2. Now, to simplify. 2 times 3 is 6 on the bottom. I have m to the 4th. Do I have any other m's? No. So I just have n to the 4th. I have n to the 3rd, n to the 2nd, n. So I would add those. That'd be 7 n to the 8th. 7 plus 1 is 8. Took care of those. I took care of my 2 and my 3. I don't have anything left on the bottom, on the top, but I still have to put a 1 to leave this on the denominator, and we are simplified. Second one, 3yx negative first times 8x to the 4th y to the negative first. So one thing I've talked about is overexerting the power. I will still have some people think this negative 1 goes to all this thing because it's all attached. That negative first really only goes to the x. So guess what? That x is going to the bottom as a positive. This y has a negative 1, so it's going to the bottom as a positive. Everything else stays up top, like this 3, this y, this 8, this x to the 4th. So I've got that on the bottom, that on the bottom, and everything else stayed on the top. Now I can simplify. Remember, these are an understood 1, right? So, once again, y will cancel out y, because there was 1 of each. I can simplify the 3 and the 8. 3 times 8 is 24. This x cancels out 1 of these x's, so I'm left with 3 on the top. And I'm just left with a 1 on the bottom, which we don't need to write, so I would just write that as 24x to the 3rd. All right, third one. There's 4y to the 3rd times x squared, y to the 4th to the negative 4th, all over 4x to the negative 3rd, y to the 3rd, whole thing squared. Okay, once again, set up a couple fraction bars. Going to deal with this parenthesis first. So this would be 4 to the negative 4th. I'm going to write it as 4 to the positive 4th on the bottom. Y to the negative 12th on top, so y to the positive 12th on the bottom. X to the negative 8th, so x to the 8th on the bottom. Y to the negative 16th, so y to the 16th on the bottom. Down here I have 4 to the 2nd on the bottom. I have x to the negative 6th on the bottom, which would be x to the 6th on the top. I have y to the 6th on the bottom. Okay, so I've got it simplified somewhat here. I'm going to change that a little bit and move it down so I can see it better. Once again, let me get all these y's together and these x's together. I have 12, 28, 34 y's on the bottom. I have 6 x's on the top and 8 x's on the bottom, multiplied together. So once again, I'm going to subtract. I'm going to end up with 2 x's on the bottom. And then I have 4 4's and 2 4's on the bottom, so I can add that and get 4 to the 6th power. And since I need to keep that on the denominator, I put a 1 up top, and we have it simplified. Next one is 4 to the 0. Anything to the 0 power is 1. Don't put 0. And then negative 3 to the negative 8th power. Oops, I don't know why I copied it like that. Negative 3 to the negative 8th power. Some people think, well, it's a negative times a negative, and that makes it positive. No, what makes it positive is that you have 8 negatives multiplied together. So this is positive because the whole parenthesis is going to the 8th power, negative 8th power. So I have a negative 3 times 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 a negative 3, negative 3, negative 3. That's 8 of those things. That's a positive 3 to the 8. But since it's a negative 8th power, it doesn't end up on the top. It ends up on the bottom. So I'd have 3 to the 8th power, 1. Now, could you still put negative 3 here? Yes, that's still true. It's going to end up being positive, though, in the end, so I just dropped it off. Either way is fine.